So let's go ahead and graph this one. When we are graphing this exponential, we need to first identify where the asymptote is. The asymptote is your k value. So in this instance, your k value is that -4. So your asymptote will be at -4. So you must draw your horizontal dashed line at -4. Remember, you must draw it. Your calculator cannot do it for you. So you have to draw that asymptote at -4. Now we can go ahead and identify the equation of the asymptote because that is exactly what we just drew. Since it is a horizontal line and it is at -4, my asymptote would be y equals -4. Now we can go ahead and enter this into our calculator and get some points so that way we can graph this. So if I go to my calculator and go to y equals, I'm going to go ahead and enter in my equation. So I have a -3 times 2 raised to that x plus 3 minus 4. Again, if you have an older calculator, this x plus 3 needs to be inside parentheses. If it's not inside parentheses, your calculator will not register it correctly. Now we go to second graph, or my table, and we are going to graph these points onto my graph. Now you need to graph as many points as possible. You won't be able to graph like 3, -196 because that's too big and my graph is not that large. Also, keep in mind that you do not have to graph these ugly decimals over here either. You can graph the nice decimals and you can go ahead and graph those whole numbers that fit on your graph. So if I go ahead and I start graphing those, I'll graph my point, -5, -4.75. Graph my point, -4, -5.5. Then I have -3, 7. -2, 10. And then -1, -16 is just off the grid. So you can't graph any more points here. But we do need to make sure that we are connecting these dots in such a way that they mimic what we see on the actual graph here. So go ahead and hit the graph button so that way you can see what your graph is supposed to look like. Now, even though I have these 4 points, my graph doesn't just stop. It has to continue going left and following this asymptote right here. If it does not continue left and follow that asymptote, then you're not actually graphing a exponential function. So let's go ahead and let's graph that. Make sure that you graph arrows at the end telling me that it continues. Now let's identify our domain and range. Your domain, no matter what it is, for all exponentials, is -infinity to infinity. Your range here is actually a little different. Because your graph is pointed downward, and remember, the reason why it's pointed downward is because this a value out front here is negative. Because it is pointed downward, your range is going to be -infinity up to this asymptote. Because the graph can't go above the asymptote. It's everything below. So your range here would be -infinity to that -4. Now you still have to put both of them in parentheses because you can't touch at that -4 because it is an asymptote. An asymptote is an imaginary line you cannot cross. But let's analyze this graph a little more. Even though it looks a little funny, it's actually still considered a growth graph. And the reason why this is still considered a growth graph is because your b value is larger than 1. Your b value here is 2. Since 2 is larger than 1, it is a growth. The reason why it looks funny is, again, because my a value is negative, which means that it's flipping the graph upside down.